Okay, we should be everyone here. How are we doing? Are we on the stream? How are we doing, everyone? Are we here? Are we live? How are we doing? Are we here? Are we live? It says I'm streaming. Let's see. It says we got the stream going. Please be on ultra low. Ultra low is good. Yeah, ultra low is good. Okay, you ready? Let's do a quick test. Let's see what the delay is, and then we'll get started here in just a second. Here we go. Get ready to type 1 when I do this. Get ready to type 1. Here we go in 3, 2, 1, go. So type 1 when I do that. Snap test right here. 1,000, 2, 1,000, 3, 1,000. Yeah, we got a good delay right there. So make sure you're up to date. Make sure you're live. So you can ignore that. I think we're pretty good. We might have a 5 or 6 second delay, but make sure you're live. But we should be pretty good right here. It says ultra low latency. So we're going to go ahead and get started. Who's ready to start? Let's see some I'm ready's in the chat. Who's ready to start? Let's see some I'm ready's in the chat. Let's get ready to do this right here. Who's ready to get started for this Kahoot? Let's see some I'm ready's in the chat. I think we're good on the delay. You ready, Connor? Here we go in 3, 2, 1. Let's go. Let's Kahoot, everybody. Let's do this. Go to the main screen here. The result of a chi-squared test of independence concludes that favorite flavor of ice cream is independent of state born. Here we go. The favorite. Oh, we need the music. So what does this mean? It concludes that it's dependent. This is from the Canvas content quiz. So if we conclude that it's dependent, there's something you should look for really quickly in here. If we conclude that it's dependent, there's something you should look for. What does that tell you about the p-value? If we conclude that two things are dependent, what would you know about the p-value? So we'd say there was evidence they're dependent. Who knows in the chat? If we have evidence they're dependent, what would that say about the p-value? When we ran this test, what would we find for the p-value? Well, let's see how many people got it. Almost got all the answers. Lower than the alpha, you got it right there. Tyler knows what's going on. Because when we reject the null in the chi-squared test of independence, we have evidence for the alternative that the p-value was lower than alpha. That was a really good question right there. And this is on the Canvas content quiz. But whenever we reject the null, we have that the p-value is lower than alpha. What is the null for the chi-squared test of independence? It would be that the favorite flavor of ice cream would be what of someone's state they're born in. What would be the null? That the favorite flavor of ice cream would be what for the state someone's born in? What would be the null? They're independent. And then if we reject the null, we have evidence that they are dependent. Is it going to be I hope it's not 10-second latency. It might just be YouTube. So exactly. What do you notice about this one right here that almost jumps out to you as a wrong answer? What do you notice about this one right here? And try refreshing the page maybe while we're doing this like review right here. What do you notice right here about this one that jumps out to you as a wrong answer? Like, what do we usually put in as like a trick wrong answer? Causal. We don't usually talk about cause in statistics. We don't like to say things cause each other. So we won't do that right here. We won't say there's a causal relationship between the two variables. Mubot. Did Mubot just randomly scream that? Mubot, you're going mad. You're going mad. How did Mubot just randomly... Mubot just really wants that. So... also right here, we have that the two are independent, which is the null hypothesis, but we're going to reject the null and have evidence for the alternative. Exactly. Exactly. So here we'll go to the next question right here. Let's hop down. Let's see who is in the lead. Who is in the lead? Remember, we're playing for $20 today. Mubot is going wild. Speedy Frog quickly jumping into the lead right there. Speedy Frog, Happy Crane, Happy Rhino. Just so much happiness. We love happiness. Let's continue on. See who's going to win with the next question right here. The next question is going to be the overall chi-squared test statistic is found by doing what to all the cell chi-squared values? Oh, let's see who gets this. It's found by doing what to all the cell chi-squared values? Let's see. It might be on a 9-second delay or so because the first answer came in at 9 seconds. Sometimes they're a little quicker. It might be because I had to change the way we're going to YouTube right now. But the way we find the overall chi-squared test statistic is by taking the what of all the cell chi-squares, the sum. Yep, and we were doing this earlier. I think I can pull up the worksheet we were doing. So we did this on a worksheet, and I think Tyler was asking, can we review it a little more? All of these cell chi-squareds are added up to give us the chi-squared test statistic. So we find all the cell chi-squareds, and we add them up to get the chi-squared test statistic. Is everyone super behind? I'm so sorry, everybody. Good game so far, exactly. So hopefully we're not that far behind, but does everyone understand that the observed values would be what? What does this 45 mean right here? Can anyone explain what 45 means right here? Yeah, I'm so sorry, Victoria. I'm so sorry. 8 seconds. No. Yeah, I think it's because I had to change the settings because YouTube was getting mad about the way I was trying to broadcast to it. Thank you so much, Andrew. So what's that 45 mean? And Whitson's right, it's the actual value. And that's the observed. Like that's an observed value right here. But what does it mean to have an observed value? So 45 is observed, you all right? So what does that mean though, that there's 45 observed? What does 45 observed mean? It means when we collected data, there were 45 people who reported being female and being Democrat. So that's what an observed value is. It's the actual amount. Does that make sense? An observed value is there were 45 females who were Democrat. We expected for there to be 36.85. That's what we saw in the sample. Exactly right, Tyler. Exactly. Can anyone show me how did we get the observed value right here? How did we get, well, not the observed, excuse me. How did we get this value right here mathematically? This is something we should all know how to do pretty quickly, and I'll show the mathematics here again. This is a review of chi-squared. How do we get this expected value right here? How do we get this expected value? What is the mathematics to get that expected value right there? Who knows? And we've got the formula right here for it with row total times column total over grand total. Nice job right there, Whitson and Tyler. Exactly right. All we do is we connect in the values that are in the row total, column total. We multiply those and we divide by grand total. So if you notice, this is the row total for this specific cell. This is the column total for this specific cell, and this is the grand total for the whole thing, and we multiply them out. Really good practice right there. Make sure you know these things. You do get the formula sheet for the test, but just understanding and visualizing it can really help to just make sure you understand, well, what is the row total? What is the column total? And then how do we get these values right here? So last but not least, we have the expected value, the chi-squared right here. And the chi-squared is going to be the observed minus expected squared over expected. So we would literally go right here and take what we observed and what we expect, take their difference. So let's go right here and do observed, which is 45, minus expected, which is 36.86. We'll round it. And we're going to square this difference, and we're going to divide by 36.86. That is the observed minus expected squared over expected, and this will obtain a what? What will this obtain right here? Observed minus expected squared over expected will obtain one singular what? Observed minus expected squared over expected will obtain what? Would we ever asked to fill out everything? Not all of them, but we might put blanks on this. We have put blanks on this on the test before and asked you to be like, what is the value here? We have done this where we're like, what is that value? So we've done that before. This won't be this is a cell chi-squared. This is a singular cell chi-squared. If you solve this out, you will get this number right here, the 1.79. So you will get that number right there. That'll get a cell chi-squared. Then we take all of these cell chi-squareds and we do what with all the cell chi-squareds? This is practice and review right here. What do we do with all the cell chi-squareds? We take all the cell chi-squareds, and it was the thing we just said a moment ago. We take them all and we sum them up. Do we not have that graphic on here anymore? No, I've got it elsewhere. Got it right over here. We sum them all up and we obtain the Pearson chi-squared. Remember, the Pearson has your p-value. So this is the chi-squared, which is the sum of all these numbers right here. And I guess we should ask this question. This will come up later during the Kahoot. How many degrees of freedom does this have? This is a 2 by 3, because there's two genders right there, and then there's 3 political labels. And so we now have 1 times 2 giving us 2 degrees of freedom. So we should know how the degrees of freedom are calculated. Rows minus 1 times columns minus 1 right there. Sorry the question, but what do you use the Pearson chi-squared? So we take the Pearson chi-squared of 5.998 and we go over to a chi-squared applet and we put it in. Now the problem is this one does not have enough decimals to show us the p-value. I'm just going to show it really quickly over here because we were doing this earlier today during office hours. Here is the p-value calculated inside of R right now. So here's the p-value using R to do it, to give us the p-value of 0.0498. But the way it is that this one is rounding in is it rounds it up to 0.05. It is below 0.05, but just barely. And we can start to see here that we start to get a little bit lower. As this goes higher and higher, the p-value will get smaller and smaller. So what do we do with the chi-squared test statistic? We plot it on the appropriate chi-squared. One last question. How do we know which chi-squared to use? How do we know which chi-squared we're using? Because of the what? How do we know which chi-squared we are using? Like, how do I know which chi-squared I'm going to use? Like, I go here and I'm like, well, which chi-squared do I use? What chi-squared am I using? Degrees of freedom. The degrees of freedom will change the shape of the chi-squared, and the degrees of freedom are going to tell you which chi-squared you're using. And then you put in the value you get right here, and it's, I wish I had more decimals on this one, but it's basically 4.98, and we can confirm that by doing it inside of R. But don't worry, we let the technology do these types of questions for you, but this is a more exact calculation. It's just rounding up to 0.05 right there. So the degrees of freedom tell you which chi-squared. So really great review right there. Excellent job, and great job on this question. Who's in the lead? Happy Crane versus Speedy Frog. Get ready, everyone. Get ready. Here we go. Next question coming. Find the degrees of freedom. Ooh, this is going to be a quick question. Let's see what that latency is. I'm not going to give any hints yet. Find the degrees of freedom. Oh, there is a latency. Oh, there's a long latency. Are we still broadcasting? Oh, there's the answers. Oh my gosh, why is there a 12-second delay? Oh my gosh. I know, big latency. We're all getting hit by it. Click in quick. What is the saying? Brian, this is a 2 by 5. Since this is a 2 by 5, what do we do right here? We reduce it to 1 times 4. 2 by 5, 1 times 4. So like first 2 times 5, 1 times 4. Does everyone see how to get the degrees of freedom here? Who's with me, like, in the chat? Let's get some yeses in the chat. If you're with me, that this is a 2 by 5, reduce it to 1 times 4. Does everyone see that? So, oh no. I'm so sorry people didn't get to answer. I am so sorry. I don't know why YouTube is doing this. I have it on ultra low latency. I don't know if YouTube's just getting mad with my bandwidth or whatever and like delaying my latency, but I put it in to ultra low latency and I'm so sorry. I saw the long delay on the question. I don't think I can change how long. There's some of these that are going to be true falses, so get ready. This one's going to be a little more luck based, but everyone knows that this is a 2 times 5, 1 times 4. So let's continue on to the next question right here. Let's continue on. Oh my gosh, the whole leaderboard just got shaken up. It could be Suddenlink. It could be Suddenlink slowing me down. They could be like, we don't like that you're broadcasting so much online. So let me look at my up rate. No, I'm doing 5 kilobytes up right now. I don't know what's going on. So Speedy Frog in the lead, Happy Crane in second place. Let's continue on right now. See who's going to win. True or false? In the chi-squared test of independence, large values of chi-squared test statistics indicate a cause-effect relationship. You should know this instantaneously. Who knows this? Oh, be quick, be quick. If you hear me say this, be quick. Select. Someone's already selected. True or false? Did the latency issues fix themselves? We're getting answers here. Large values of chi-squares. Oh, what did we say up here? What do we say right here? Should we ever talk about cause and effect in statistics unless we're doing a designed experiment? So what is this keyword right here? When you see cause effect on the test, oftentimes, oh no, this is going to be an interesting race to the lead, interesting race. When you see cause and effect, this is kind of a trick thing that we put on the test a lot, but cause and effect is something we don't usually have good evidence for in statistics. So if you see cause and effect, that's usually a trick on the test. So do not expect to be saying yes to things that are cause effect. We don't usually have good enough evidence for cause effect. So this is a big trick right here. Do not be tricked by cause effect. Let's see who's in the leaderboard right here. All the crazy quotes. This is absolute insanity, and I'm gonna chalk it up to, this is the most I've seen the leaderboard just go around and do craziness. I'm chalking it up to the latency, and we need to make sure this is fixed for the next Kahoot. So let's see who's gonna win with the next question right here. Let's see who's gonna win. Next question is, find the expected count of music failed. Oh, be quick right here. I don't even know if anyone's gonna answer. I should put 60 seconds because I should have been like, we're gonna have crazy latency. Music failed. Let's talk about the mathematics here. Music is going to have this for its column. It's going to have this for failed. You're going to take this right here for the total. So row total times column total over grand total for music failed. Row total, column total, grand total. 4 people got it. Let's show the mathematics on this. Who can put the mathematics in the chat? Remember, this is more practice. There will be one winner. I'm so sorry for the latency. We need to go right here. I'm going to put it right. Don't expand. Good. So we need to go to row total times column total over grand total. So row total times column total. Here's the column total over grand total. And then just did I put the right answer in the chat? There it is right there. It should be that, right? Whew. So afraid I messed it up. Exactly. I didn't have my calculator right. No, Connor. I should warn, I think there's one more. So get ready if you have your calculator out. Get your ready. It wouldn't let you answer. No. Brian's head is in the way. No. Oh, is my head in the way of the oh. I didn't even see I was blocking that 342. Why is it 82 since 82 is the smallest number? Oh, did I make a mistake? Did I do music? 367. Oh my gosh. Did I grab the wrong number? I maybe made a mistake. And how did I make a mistake on this and then make a mistake again? Let me double check my mathematics right here. So it should be row total 367 times 367 divided by 342. And there it is. Yeah. It's oh sorry, no, Tyler has it right there. And we're doing music. So is this making sense right here? Let me show it visually. I'm going to take a picture and show it visually right here so everyone can see the visual on it. To do this visually right here, which might make it a little bit easier to understand, we do row total times column total over grand total. So the row total for photography or music failed, it's music failed, right? Is going to be failed right here and music. And then we do that. There is the equation. Row total times column total over grand total. Just knowing that right there. So hopefully that helps. You might be thinking about Mallory for the checking the, yeah, there we go. Andrew, great answer right there, Andrew. Andrew says we do that to check the smallest cell count. So if you want to check to see if we meet the expected cell count condition, you can take the smallest ones right here, which are going to be these. And this one would have the smallest expected cell count. Does that make sense, Mallory, right there? What does the equals do? Which part of the equals? And great question right there, Mallory. So this is the smallest expected cell count would be in success photography. And which equals thing, Marissa, which one are you talking about with the equals? So this would be the smallest expected cell count right here. And as long as it's greater than 5, we pass the expected cell counts greater than 5 condition. But what does the equation give you? Oh, yeah. This is an expected cell count. So great question right there. Expected cell count. So this is expected cell count right here. These are expected cell counts. So that will give you the expected cell count, which is what we would expect by random chance. The cell chi-squared is going to be the observed minus the expected squared over expected. And that'll give you a cell chi-squared. So that'll be a cell chi-squared right there. So good practice right there. Exactly. So really great practice, everyone. Just keep practicing. That's what we're here to do today. We're here to get some great grades and practice. Let's see who's in the lead right now. Whoa, Happy Crane was the only one who got that on the leaderboard. Happy Crane going to run away with this. We got to find out who Happy Crane is by the end of this. Let's see who's going to win right here with this long latency. I'm sorry. If we use a 98% confidence interval, what is the alpha level for the corresponding two-tailed test? 30 seconds. This one should be pretty quick if you know it. We use a 98% confidence interval. What is the corresponding alpha level on a two-tailed test? 98% confidence. Two-tailed test. So if you have 98% inside and you have two... if you have 90... Needs water. Almost got you there. So classically, a confidence interval can be done to do a two-tailed test with an alpha level that is the complement of it. So when we have, no, Rocky Top, why are people getting kicked? Kahoot, stop kicking people. So if you have 98% on the inside, which this is not properly drawn, 98% on the inside, then the corresponding two-tailed test will be 1 minus 98%, which is going to be a 2% alpha level, or 0.02. Either way is fine to say it. You could say an alpha level of 2% or 0.02 alpha. But this right here, just lost connection to? How many people just lost connection to the Kahoot? What is going on today? Did Kahoot get mad at us? Is everything all right? People still in? Maybe Kahoot had a hiccup. YouTube kicked YouTube. We'll see who's in the lead right here. The leaderboard is just jumping around. The leaderboard is just jumping around today. It's all craziness here. Let's see what the next question. Sorry, this is like the craziest Kahoot we've had. We're still connected. Wacky Mondays. It is Wacky Mondays. Can we get Crash in here? Oh, is Crash not up here on this screen? Why is Crash not up here on this screen? Oh, is he? Wait. Daily event. Daily event. There we go. It's Wacky Mondays. Let's do this. All right, let's do this here. Let's go on to the next thing right here. Sad Mondays. No. Find the t-statistic. Find the t-statistic right here. So you got to know how to find the t-statistic pretty quickly on this one. I should do 60 seconds. This is practice for the final right here. How do we find the t-statistic? If you have your calculator out, and you should have told people, put your calculator out. Get ready. I got Francis right here. Sorry, Francis. How do we find the t-statistic? If you win this Kahoot, you are a Kahoot master. So what do we do? Who can explain to everyone in the chat how we find this t-statistic? How do we find this t-statistic right here? How do we find this t-statistic? What do we do to find the t-statistic? How do you find this t-ratio right here, this t-statistic? Why is it called a t-ratio? Who knows mathematically? So these are going to be the p-values right here. Here's all your p-values. Here's the degrees of freedom for the two-sample t-test. Here's your confidence interval, which the confidence interval contains 0, so it's not statistically significant. Nice job right there, Layla, right there. Excellent work, Layla. Its name is Francis. His name is Francis. They named him that in the chat. And so nice job right there, Victoria, showing the mathematics also. Because it's the difference divided by the standard error. Like, you could really quickly abbreviate the test for this. If you go through and do the test, you could just say that all we do is we just take y bar 1 minus y bar 2 and divide by the standard error of the difference of the two. And that is the whole statistical test. That's the t-statistic. And what is y bar 1 minus y bar 2? That is just the difference between the two sample means. So this is just the difference right here. And that's all the test is the difference standardized. I'm so sorry, Victoria. Did you get kicked too? I hope not. This will be on the equation sheet. What will be on the equation sheet is y bar 1 minus y bar 2 over square root s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. This is what will be on the sheet, but the top part of this is just the difference right here between the two sample means. That's what the difference is. And the bottom part of this is going to be the standard error of the differences right here. So that's the standard error of the difference. Top part is the difference, and the bottom part is the standard error of the difference. Yeah, I know equation sheets are so nice. Like, you just need to know how to use an equation. Still, that is so weird, Victoria. I'm so sorry, Victoria. And you got it. You know how to do it. No. Francis is rooting for everybody. We need Happy Parrot on here. Fuzzy Condor. Maybe that's... See a condor? I don't know. So let's continue on here. Bronze Dolphin. I'm rooting for Bronze Dolphin. Bronze Dolphin, you got my vote of success right here. Let's do this. Question 8. Find the p-value for the greater than test. Find the p-value for the greater than test. I know, Victoria needs her second place streak. We gave Victoria a prize, though. Oh, people are really confused on this one, or the latency's eating us up. Why, YouTube? I fixed the latency. So what we need to look at right here is here's where we landed. This is the T statistic of 2.5. This is the standardized distance it is away. That's the actual distance. Oh, no. No. Okay, Francis, we're gonna get Tiny Brian here. And, oh, that's Brawl. There's Mega Brian. Ah, it's a whole family of Brians. Hey, here we go. We need this Brian right here. Wrong Brian. There we go. Wait, why is that? Wrong Brian. There we go. I can't find the right picture. There we go. Okay, here we go. There we go. There we go. Now Francis, he's taking over. Okay.
So how to wrong voice.
Okay, Francis is huge. Okay, so when we look at this, I'm gonna have to go back to
normal voice. Okay, so when you look at this right here, Tiny Brian makes his return with normal size Francis on my shoulder. So this is where we landed with this difference. You notice how this is 0.043? But when you think of this T statistics, I'll find a voice for Francis. When you look at this T statistic, you should just think of it as a what. Every T should be thought of as just a what. TV for Tiny Brian. Every T statistic should just be thought of as a what. Every T, when you see it, should just be thought of as a what. I mean, it is a T statistic. T statistics are a thing. When you see a T statistic, just think of it as a this, though. I love TV in the chat. So what do you think of when you see a T statistic? What do you think of? T statistics are just like what statistics? T statistics are just like Z-scores. Exactly. They're just like Z-scores. They're the same thing, basically. So this is how many standard errors we are above the mean. Does that make sense? We are 2.5 standard errors. This is a standardized distance. How much of the area is below this line? So how much of the area is below that line? So when you look and you see the less than, the probability of less than this T right here, you can see that 99.34% is below there. So how much would be above there? We can just subtract from 100%. A lot. I like that right there. Winston says a lot. We can just subtract from 100%. And that's what we have right here is we have the remaining portion below. Did I enter it in the wrong way? Did I forget a 0? All the answers were wrong. Oh my gosh. I better not use this on the final Kahoot. I was like, I don't remember entering that extra 0. So sorry about that. We all make mistakes. That is Brian's one mistake today, other than the latency, which is not my fault. It's going to lean into the mic. I'm just going to lean into it. Lean into the errors. Errors plus. Oh my gosh. Mubot's not even counting our errors. Let's bring Mubot back here counting errors. I wish the errors would just start automatically. Errors are back on right now. Errors are back on. Let's see who's winning this game right now, though. Tiny Brian's going to go even more tiny right here. Tiny Brian. No, I'm on the right size right now. I'm so sorry, Andrew. We're going to fix this. Errors are back up. Mubot is making all those errors. So we'll continue on right here. So we are at the final 2 questions. True or false? The sample size of each group must be the same for a 2-sample T interval. Shoot, 20 seconds. It must be the same. You must have the same amount of Florida students and the same amount of UT students. You must have the same amount to do a 2-sample T test. Is that a condition? I like the music, though. This is 100% false. So when you look at this, we were showing some of the equation earlier. I'm so sorry, everyone, for the latency. Thank you so much. So when you look at this right here, we have the following equation, and you can have different sample sizes for each group. So this equation, which leads to your T statistic, can have very, very different sample sizes. So one big thing I want to make clear, and let me give a shout out here to videos that don't have latency. In the exam review, so let me go to the exam review page. Huge shout out if you're watching this right now. Please check out this playlist. This playlist here has a lot of really good review videos, and I'm going to drop it in the chat too. So we're going to go over here. We're going to click on this, and let's go over to the 2-sample T-test right here. Let's go to open a new tab. There we go. We're going to stop this video, and we're going to learn about HelloFresh. Skip HelloFresh. There we go. So we have here. So one thing, there's Brian with shorter hair. Let's hop back to where I can see everybody and what's being said. Too many windows. There we go. So what we have going on right here, I look so amazed by that. I'm like, whoa. So with this right here, and let me go to 2. There we go. It should have the good. I like when it has the video number on it. Is that person is the first place? It's actually Brian. So there's Brian, short hair Brian. And what I do at the very start of all these videos is I explain why we're going to use the 2-sample t-test. So I go through and then guess what I do? I label all of the notation. So I go through and do every bit of notation from all of this. So you go through and you see all of the notation for every problem. So this is very important right here to go through and understand all the equations. I talk about the degrees of freedom formula, which we will not use. I drink a Red Bull. Man, I miss Red Bull. It's a coconut Red Bull right there. I filmed all these videos in one day right here. I sat down and filmed all these videos. But I go through, I talk about the chi-squared. So here's your degrees of freedom. Here's how we're going to calculate an example problem right here. But if you go through, each of these videos are meant to be kind of a short walkthrough of a problem. And then we go through and write all the nulls and alternatives. And I talk through each portion of this and how we go through and do this. Here's the 2-sample. To shotgun a Red Bull. Love it. And so we talk through every single condition. We do all the formulas. We write them all from scratch right here. And we talk through solving this. So I show every formula and go through and do it from scratch. And I talk through the whole thing. So please check out this playlist. It's in the links. I do it for each one of these, like a z-test right here, the 1 proportion z-test. I go through each example and I solve an example problem and solve the z-score or solve the t-score. And I go through and I reject the null or fail to reject the null. Please check these out. I think it's going to be a huge help for the test, but try working the problems along with me. Okay, so what do we have right here? Happy Crane in the lead. Be quick. Okay, let me just say this. Be very quick for the last question. Hint, hint. Are you ready? I'm going to give it like 8 seconds. Be very quick for the last question. Here we go with the last question. I'm counting on you. I don't know. Speedy Frog. I'm counting on you, Speedy Frog. Let's do this. Which is a way to check the nearly normal condition? Which of these is a way to check the nearly normal condition? And when we do the nearly normal condition, we're trying to see if the normal curve is a good fit for the data. So there's one way to do it. We can do it with a goodness of fit test. We can also do it with a normal probability plot, which tells us if it's pretty normal. We can do it with the central limit theorem, which has the sample size conditions we must meet. And last but not least, we can also do it with a histogram by investigating the histogram. So what are the answers to here? I think I did it correctly. They're all correct. Every one of these is a way to check the nearly normal condition. So when you check with a normal probability plot, you're asking, is it straight enough? When you're checking with a goodness of fit test, you're asking, is the p-value above 0.05? When you're checking with a histogram, you're seeing if it mainly goes underneath the histogram well. And then the central limit theorem is when we need at least 25 if it's skewed, but at least 100 if it's very skewed. Let's check out this leaderboard right here. You got top 5, Victoria. Nice job keeping the streak alive. Who here is the top 3 though? Speedy Frog, number 3. Fuzzy Condor. And then who's number 1? 9 out of 10. Love it. What was missed? Happy Crane. There from the start. Considering I had about 7 seconds to actually answer most questions and not top 20. Top 5 as well as number 3. Number 3 right there. You were Speedy Frog. Great job, Tyler. I know where Tyler's at. Rooting for Tyler right there. Number 1, make sure to email me. Now, we will be doing a huge Mega Kahoot, and I will be double checking the latency on the Mega Kahoot because we're going to hopefully show up to the Mega Kahoot. We're going to have big prizes. We'll do 50, 20, 10, I believe. So we're going to have big Mega Kahoot prizes. So it's, don't worry, I don't. I'm like, okay, let's do it. Let's go crazy. It's the end of the semester. Merry Christmas. Tiny Brian's got his parrot right here. So, no, this one's only for the top 1, but the Mega Kahoot, we do gift cards for all top 3. So the Mega Kahoot is when we do gift cards for all top 3. And then sometimes randomly I've done it for the other ones. But just for regular weekly Kahoots, we do 20 for first place. Exactly. Tyler, yep. Tiny Brian's got his parrot right there. But let's go crazy for Christmas. Let's do 50, 20, 10 for the Mega. I think that'd be good right there, right? Oh, so awesome, William. Glad it helped out. That's the whole goal right there. Whitson, it's $20. $20 for first place. Did you win, Whitson? Did you win? If so, that's awesome. Excellent work. Any other questions? Layla, you're welcome so much. Thank you for everyone showing up. I'm glad it helped out. That's my goal with these. I try to think of questions. And then also, did anyone do the Canvas content quiz while we were doing this? Who has the most amount of points this semester? We should look at the most hours. I'll tell you who's winning. You can check your points. Hours is where it's really at because points have totally messed up the economy. I just got the p-value question wrong on Canvas content quiz. Could you help explain it again? So is it but remember, I might change the question. So if you look at the p-value one, which can I look at this question? Why does it want me to stop sharing? I don't know why it's like, stop sharing your screen. Okay, so if we look at this one right here, can I look at the question? They get pretty good detailed reports. So remember, the questions might be a little bit different. Did you get number one, Rocky Top? If so, congratulations. Excellent job. Let me go into this quiz and bring up the question. So I do change the question on these. This one was one I changed. I didn't do the exact same. So I think, okay, here we go. So let's go look at the question on this. And the question right here is, I'm so blind. I'm so blind. The question is find, oh, that's the t-statistic. I don't want that one. We want find the p-value. Where did I put the p-value? Here we go with the p-value. So with this one right here, finding the p-value, I love everyone's such good camaraderie here. This is finding the p-value for the greater than test. So the p-value for the greater than test would be what for this? And let's fix this. Let's go here, fix this. So the p-value for the greater than test would be what? Ah, yes, yours is the not equals to. So the p-value for the greater than test is what? The p-value for the greater than test is what? I love the positivity. Stat Nation right here, positivity, that's what we do. So the greater than test is going to be the area to the right of this line. That's the greater than. And then how would you find the not equals to? How would you find the p-value for the not equals to test? And then how would you find... Yep, exactly. Well, not the confidence, but 1 minus this one, the less than test. Because below this line is 99.34. So that's below the line. So 1 minus that will give us the area above the line. And then that's the blue area right here. But you want the does not equals test. So what do you have to do to the greater than, or to this small one right here to get the does not equals test? And I won't show it, but it's on the screen somewhere. What would you do to this to get the does not equals? Because this is the greater than p-value right now. Because the greater than and the less than add up to 1. What would you do to that right there? And here, I'll show it visually. But we have the greater than, right? Here, let's do this example. Let's kind of do it this way. So we're going to do a kind of a similar example right here to this question. I love the point competition. I'm seriously considering next semester just doing... like adding points to people and doing it that way only, because I'm going to go through and look at the points, but I think a lot of people are going to be up there with points. I'm going to make a spreadsheet and then do the bonus at the end of the semester, but a lot of people got their 2-point bonus. If this p-value right here is, let's say, sure, this is 80%. So this p-value right here is 80%. Then what is this one going to be? Maybe it needs to be 90. As I change the question. Just want it to look visually decent. If that's 90, then what's the greater than test? If the less than test is 90, then what's the greater than test? And so this will answer our question right here on how we get it. If the less than test is 90, what's the greater than test? If the less than test is 90, exactly, Brianna, great work there, and Rocky Top, great work. So then does anyone know what the two-tailed test would be? That's a bad one. Got to do it in line with the other one. Does anyone know what the two-tailed test would be? What would the two-tailed test be? What would the two-tailed test be? So in the two-tailed test, you reflect it on the other side. Now be careful. I hope my drawing is good enough to see. Wouldn't be 5%. Because this right here is the same as this right here. And this on the other side is a reflection of it. Yep, there you go. There you go. The two-tailed is always double the smallest. So and if you look at what we have in the graphic on this question, you'll see that this is that little sliver of 0.66% right there. And then we would double it and we'd get it over here. This is the p-value for the two-tailed, is the addition of both of these. Does that make sense right there? How we get the two-tailed p-value is we double the smaller one. Is it making sense right now? Let me bring up the graphic we had. So who's with me on this right here? Who follows this, how we're able to figure out the less than and the greater than add up to 1, because you could just put this down here, and the less than the greater than add up to 1. So that's how the less than the greater than work. And then the does not equals is you reflect it on the other side. You do like a reflection, and it's just double the smaller one. So great job, Brianna. Great job, everybody. It's just practice. And these are questions that are on the Canvas content. Did anyone ace the Canvas content quiz yet? Did anyone say, I'm going to take the Canvas content quiz, and did you get an A on it? I'd love it if someone got an A on it. We did many of the questions on there. So it's, yes, Victoria, you get an A on it? I'm hoping so. And so this should give you a good opportunity. Nice job right there, Layla. So got to play along for the Kahoot. And did we figure out who won? Was it Tyler won? Who won? Was it Whitson who won? I don't know who won. I'm sure they'll email me. But any other last questions? You haven't even touched it yet. We've got until tomorrow night. This is our help quiz, and I'll have to resend out the link. Hopefully I didn't cause too much confusion. Sorry about the latency, everybody. Sorry. Any last questions? What's everyone wondering about? I'm wondering what's for dinner. You know what? Chicken pot pies, maybe. We got chicken pot pies. Oh, jeez. I got the question about, social political. You got it. You got it. Is it the not? I don't. Is it the equals, not equals pair? I've got 2 papers due tonight. You got this, Tyler. You got it. You got it, Tyler. You know what, Tyler? Check it out, Tyler. Here, wait. Oh, why is this one open? Where is it? Did I open up Photoshop? I thought I had After Effects open. Wait, what? I was going to show you it real quick. Okay, now my computer is going insane. After Effects. After Effects. I think. And which one is it, Rocky Top? What were you wondering about, Rocky Top? There we go. Here we are. I've almost got this done right here. So here you go, Tyler. Just so you know, I've been working on the background right here. It's got all these layers and everything to work with. So, but there's things happening, Tyler. So stay tuned. I might just send it to you. Like you said, I'll publish it as a video, but you will have your own, you will be in the intro. So, but in Saskatchewan Fall 21 survey, 39 students reported having very liberal social political views, whereas 56 reported having very conservative views. Awesome. By the way, on Canvas, it is showing that the Canvas content quiz is due December 2nd. Is that right? Oh, yeah. Oh, I think I messed up, Victoria. I keep thinking things are due. Nights are not due. Oh, everything for all my classes is just all jumbled in my... Seriously, I'll say this real quick. Living in the COVID times is like living in a time warp. Time just doesn't seem real at times. Like a day goes by and I'm like, what day is it? And like, I miss walking down to campus. I miss like going outside. Assume the conditions are met. Compare 2 independent means are met. Use the jump output below to answer the following questions about the differences in the Saskatchewan. What are the correct hypotheses? So the correct hypotheses are we're going to compare the 2 means, right? So we're comparing very liberal to very conservative. And so you want to compare the 2 means. No, you're totally right, Victoria. Good check right there. Yeah, Tyler, it's insane. It's absolutely insane. I slowly like lose my mind by like, what day is it? What time is it? Is it no longer the weekend? And I'm just like, one of my biggest fears is always, one time, I should tell you all the mistakes I've made while teaching. One time I sent my students to the wrong room for a test. That was pretty bad. I sent them to a broom closet, and I had to like stand at the door and be like, the room's over there, the room's over there. And then I think that's the worst I've done, but I'm always afraid when I say like a date or a time, even though I was putting the date for the test earlier, and I'm pulling up the Canvas content quiz here, Rocky Top, to take a look at it. Where's Canvas content quiz? So I think that one's just the null and alternative, right? So that'll be the 2 sample T, null and alternative. But I'm always afraid of putting wrong info out there. Oh yeah, you got this. Oh, you got this. you can narrow down some answers. It says compare. So assume that we've compared the two independent means. Questions about the differences in exam 1 scores. Yeah, you got this. You got this. So use some process of elimination. Awesome, Tyler. Have a good night, man. Have a great night. You're welcome so much. I really appreciate it, Tyler. Wonder how we're doing on the response rate. How many more responses did we get? 24, which means we got like 15 responses during class. I need to send out a link to remind people to do the responses. We're doing better in my other classes. So, and then does it give a preference? Does it give a preference for which way we should do the test? Does it give a preference for which way we should do the test? And that's kind of the big hint. Does it say anything about we're testing to see if this, or this? Does it give a preference about which way we're doing the test? So you know the null, and then does it give a preference about which way we're doing the test? Could be. And that's, remember, we always check the wording of the question to see which way we're going to do the alternative. So if there's no strong indication, then I would go with that right there, maybe. How's that sound, Rocky Top? Are you good to go? I think you got this. I have faith in you. Last Canvas content quiz. Then we're done with them. No more Canvas content. We got our projects back. If it doesn't give it any indication, then we don't do a sidedness. We don't do less than or greater than. We always just go with the kind of like, let's just do the not equals to. We just want to compare them, so we're just seeing if they're equal to each other. So if we're just going to compare two things, we can see if they're equal to, and the alternative should be not equal to then. Exactly, Victoria. I put a whole bunch of questions on here from it. So I was like, I'm going to make sure they get, really good advice. And I did change some of them. I changed some of the wording on some of them, but this Kahoot is very, very, very Canvas content quiz based. So most of your questions should have some good luck on it. I think. Any other last questions? Is the expected cell frequency based on the researcher's opinion? Would it be? How do we find expected cell frequency? How do we find the expected cell frequency? What do we use to do expected cell frequency? What do we use to do expected cell frequency? Submit, see what you get. Submit and see what you get. What do we do to do expected cell frequency? Expected, did I delete that C? There, I did delete it. It's like, did I not write that? For expected cell frequency, it's row total times column total over grand total. So would that be based on a researcher's opinion? Would the formula here be based on a researcher's opinion? Since it's row total times column total over grand total is expected cell count, which is expected cell frequency. Counts and frequencies are synonymous words. Like it's like how frequently did something occur? That's the count of how many times it did occur. So frequency and count are the same meaning. So this would be based on the formula and not on the researcher's opinion. And I think we'll see if anyone else has any other questions. Any other last questions here? Did you submit, Rocky Top? Don't worry, there's always a second attempt, but you should be on the right track. We'll see if there's any other last questions. Okay, Brianna's got it right there. Great job, Brianna. I'm on such a delay. That's why I'm waiting even longer. But with that, if there's no last questions, we're going to end off strong here with some Mega Man music. Let's do this. Yes, did you get it? You're welcome, Victoria. You're welcome, Rocky Top. You're welcome, Brianna. Great job. We'll see you Sunday. I'll be doing more reviews. Stay tuned for the reviews. I will see everybody later. Bye for now.